Alright, we're on page 51 looking at your warm-up for quiz 2. Number 1 says, what is the type of relationship between P and V? Number 2 is asking what will happen to pressure if volume is increased. What type of relationship is that? What will happen to volume if temperature is increased? Blah, blah, blah. All 4 of these questions can be at least partially answered by a trick that I taught you earlier in the unit. Remember, the trick was to write the letters P. Oops, this is my dead pen. Where is my not dead pen? Oh, here it is. Okay. To write the letters P, T, and V in alphabetical order, just in a straight line. Okay? In alphabetical order, in a straight line. And if you want to compare 2 of those variables, like number 1 asks us to compare P and V, then whatever the third one is, we're going to hold that still with our pen. And then we can see what happens to one when we change the other. So I hold temperature still, because number 1 only wants to know about pressure and volume. So I'm going to hold temperature still and see if pressure goes up, what's happening to volume. When pressure goes up, volume goes down. When volume goes up, pressure goes down. If one goes up and the other goes down, that is an indirect relationship. So my answer to number 1, pressure and volume, are indirect. Number 2 asks, what will happen to pressure if volume is increased until it is 3 times larger and temperature is held constant? So, again, part of this we can answer just by checking. Temperature is held constant. I'm going to hold my pen there. They're saying volume is increased, so I'm going to move my page. I know that when volume goes up, pressure is going to go down. I know that from this trick, when volume goes up, pressure is going to go down. So I go look at my answer choices. If I know pressure is going to go down, then I know it's not A or B. C says pressure will decrease. D says pressure will decrease, so it's got to be one of these. It says to 1/3 of its original, or it's 1/6 of its original. Well, I also know from Boyle's law that this indirect relationship is 1-to-1. Basically, for every 1 change in pressure, there's the same factor change in volume. So if the volume is 3 times larger, the pressure is going to be 1/3 smaller. So C is going to be our correct answer here. For 3, what is the type of relationship between T and V? So if they want to know about T and V, then I'm going to hold pressure constant this time and not look at pressure. And if V goes up, T goes up. If V goes down, T goes down. So if they both go up, or if they both go down, that's a direct relationship. So temperature and volume have a direct relationship. Number 4 asks, what will happen to volume if temperature is increased by a factor of 5 and pressure is held constant? So let's hold pressure constant. We're increasing temperature. If pressure is held constant and I increase temperature, I see that volume is also going to go up. Again, if temperature goes up, volume is also going up. Whoops. So if I know volume is going to go up, I know it's got to be either A or B where it says increase. It's not going to be C or D where it says decrease. And this also, if we look at Charles's law, there is a 1-to-1 relationship there. So if volume, if temperature is going up by a factor of 5, volume should also go up by a factor of 5. Let's look at number 5. Carbon dioxide has a pressure of 724 mmHg, that's millimeters of mercury, and they tell us in the problem that that's a pressure, so I can label that P for pressure. It's at 28 degrees Celsius. What would happen to the pressure if we decrease the temperature to 19 degrees Celsius? So they tell me that Celsius is temperature. That means this other one is also temperature. they're telling me that 19 is after it decreases, so that's my second temperature. 28 is my first temperature. They're also asking what will happen to the pressure, so that means pressure is what I'm looking for. If they're asking what will happen to the pressure when I change it, after a change is always going to be your 2, which means 724 before my change is my number 1. I also have to know that the temperatures need to be in Kelvin for me to use them, so Celsius plus 273 will be Kelvin, and 28 plus 273 is 301 Kelvin. You may want to even cross out this other stuff so you don't accidentally use it. Okay, 19 plus 273 is 292 Kelvin, and again you might even want to cross out this other stuff so you don't accidentally use it. We need a formula that has P1 and P2 and T1 and T2, and there's one formula that we can always use every time. P1V1 over N1T1 equals P2V2 over N2T2, and then just if there's anything that they left out of the problem, we scratch it out of here. So this formula does not have any volume, so I can just scratch out volume. This formula, this problem does not have any moles, so I can just scratch out moles, and I'm left with P1 over T1 equals P2 over T2. And now I just plug stuff in. P1 is 724 over T1, that's our 301 Kelvin, equals P2, we don't know, over T2 was 292. As always, if you are comfortable with the butterfly method or cross multiplying, you are welcome to do that. I usually just simplify the fraction I see here, 724 over 301. That will get me 2.4053 blah 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 equals P2 over 292. And then to isolate P2, I just have to move the 292 over. Right now it's being divided. I need to do the opposite, which would be to multiply it on both sides. Multiply by 292 on both sides, which will get me 702.35 for my answer. And if you notice we didn't pick any units earlier, we should probably go back and do that. Remember, your 2's and 1's have to match units all the time, so if P2 needs to match P1 and P1 was MMHG, then P2 must be MMHG, which means my answer must be MMHG. Let's look at number 6. This park has a helium balloon with a volume of 2.3 liters, so they're telling me 2.3 liters is a volume. At 1.1 atm of pressure, they're telling me 1.1 atm is a pressure. And a temperature of 25 degrees Celsius, so they're telling me 25 degrees Celsius is a temperature. This is all before any changes happen, so all of these are going to be my 1s, V1, P1, and T1. Then they say, if the temperature increased to 32 degrees, so that's going to be my T2, and pressure decreased to 0.95 atm, that's going to be my P2. They ask what will be the new balloon volume. So they're asking for a volume. Remember that new is code for 2, so they're asking me for V2. Also remember that your 1's and 2's need to match units, so V1 was liters, V2 should also be liters. And that means my answer should be liters. And remember, we're not allowed to plug Celsius into these formulas, so we need to change this to Kelvin. Add 273 here, add 273 here. 25 plus 273 is 298 Kelvin, and you might want to scratch this out so you don't use it by accident. 32 plus 273 is, running out of space, 305 Kelvin. And then you might want to scratch out this other so you don't use it by accident. We need a formula that has a whole bunch of variables, so we're going to go back to the combined gas law. It has two V's, which we need. It has two P's, which we need. It has two T's, which we need. It also has two N's, which we do not need. So guess what we can do? We can just cross those right out. Now we just have to plug stuff in. P1 is 1.1. It's times V1, which is 2.3, over T1, which is 298 Kelvin. It equals P2, which is 0.95, times V2, which we don't know, so I'm just going to write V2. You could also write an X if you prefer, over T2, which is this 305 that I barely fit on the page. Okay, this is another section where, again, if you are comfortable cross-multiplying and you know how to do that, or the butterfly method as your math teacher may call it, then you are free and welcome to do that. I, again, prefer to simplify. So first I'll put this in my calculator, 1.1 times 2.3 divided by 298. Again, 1.1 times 2.3 divided by 298. When I do that in my calculator, I get 0.008489, blah, 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 blah. I don't have to write all of it down. My calculator saves it for me. And I know that equals this stuff. I can also simplify this right here, 0.95 divided by 305. 0.95 divided by 305, which is 0.00311, blah, 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 blah. And that'll be times V2. So to isolate V2 and get V2 by itself, I need to do the opposite of what's happening with this 0.0031 number. I need to move it over. So to do that, if it's being multiplied, I just divide. And when you take this first one divided by the other one, you should get it rounds to 2.73 liters. This was an L, in case we forgot. Alright, time for your quiz.